Hello, we are going to start tonight with a point slope form of a line. So this is the second way that you can represent the equation of a line. It has y minus y sub 1 equals m parentheses x minus x sub 1. Okay. M is our variable that we often denote with slope or relate with slope, and then x1 and y1 or x sub 1, y sub 1 would be an ordered pair on that line. So with our first example, what if we start with a point of negative 2, 3 and a slope of 4? We can substitute those values into our equation. We would get y minus, and then y sub 1 is the y coordinate 3. So y minus 3 equals, our m value is 4, slope of 4, parentheses x minus, and then the x sub 1 value, which is negative 2. So x minus negative 2 minus a negative, I'm just going to write as positive 2. So this would be point slope form. You don't have to distribute, you don't have to move anything. This is it. So this is really handy if you know a point and a slope, and that's it. So with our first example, identify the slope and a point on the line. Okay, the slope would be the coefficient. So in this case, our slope is 1/3. And then the point is going to be the ordered pair where this is the x1 value and this is the y1 value. It's important to remember that the negative is part of the formula. So it's kind of like when we did the absolute value problems and you wanted to almost think about it as the opposite sign. That's what we'll do here. So the point, the x coordinate is x minus 8. So the x coordinate is 8. And then the y is y plus 1. That means that it must have been written y minus negative 1. So our y value is negative 1. So this is the equation of a line that passes through the ordered pair 8, negative 1, and it has a slope of 1/3. What we're going to do next is make our table of values of this equation. Okay. The nice thing is that we know an ordered pair already, so I'm going to put that in our table. Negative 2, 3. From here, we can use the slope to fill in additional table or additional values. What the slope says is for each additional value of x, so if our x is going up by 1, the y coordinate is going to go up by 4 if it has a slope of 4. So negative 2 plus 1 is negative 1. 3 plus 4 is 7. We're going to do the same thing again. So add 1 to the x and we get 0. Add 4 to the y and we get 11. And 1, add 4, 15. Add 1 to the x, add 4, 19. So with just a point and a slope, it's pretty easy to be filling in a table of values. It's that same mindset that's helpful when you're graphing an equation in point slope form. Again, it's pretty handy to just start with the ordered pair given. So what we're going to do is start with the point. So our point is negative 2, 3. And then the slope is 4. So we want to use rise over run. In this case, that's 4 over 1. So from our ordered pair, we're going to rise by 4 and then run by 1. And rise by 4 and run by 1. Kind of off the graph. We can also work in reverse. Think about it as negative 4 over negative 1, which reduces to 4, so it's the same slope. But what this says is that we're going to go down 4 and then to the left 1. So it's working in reverse. Okay, once you've plotted a few points, you probably have enough to draw on your line. And that's it. Okay. What should we do next? Let's do write the equation of the line given in slope-intercept form. So once again, I don't think we've talked about this yet. It's y equals mx plus b. So what we want to do is distribute the slope, and then we're going to isolate the y value. So we have y minus 3 equals 4 times the quantity x plus 2. I just rewrote the problem from below. And we're going to distribute the slope. Y minus 3 equals 4x plus 8. And then lastly, add 3. Y equals 4x plus 11. This is handy if I ask you a question about slope-intercept form, where you can start it in point-slope form, and then pretty quickly, in just a couple steps, you can write it in slope-intercept form. Okay, what is the y-intercept of this line? Well, we can see it a few different places. One of them is at the table. If x is 0, y is 11. Another place is in our slope-intercept form. We just found that the y-intercept is 11, so we know the answer is 0, 11. One last thing that we can do is use the equation and substitute 0 in for x. So we can algebraically find the y-intercept too. Y minus 3 equals 4, 0 plus 2. So we get y minus 3 equals 4 times 2, which is 8. So y equals 8, and then adding the 3, 8 plus 3, we get 11. So there's multiple ways of representing the y-intercept. Okay. Next example, write the equation of the line that passes through 2, 5 and negative 4, 8. What we need to write the equation is a point. We already have one. Actually, we already have two, and it doesn't matter which point we use. But we need to find the slope. So let's find the slope using the difference in y's divided by difference in x's. So the difference in y's is 8 minus 5 divided by the difference in the x values, 4 minus 2. Okay, 8 minus 5 is 3, 4 minus 2 is 2. So our slope is 3/2. To write our equation, let's use the 2, 5. Y minus, the y value is 5, so y minus 5 equals 3/2, parentheses, x minus 2. Done. How easy was that? Pretty easy. Okay, you could have also written the other equation, or ordered pair. What that would look like is y minus 8 equals 3/2 x minus 4. So either one of those would have been acceptable for a final answer. I really like point slope form because it doesn't require a lot of work. The hardest part is finding the slope. And then once you have the slope, it's just plugging numbers in. You don't have to really do any algebra to rearrange or solve or anything. Okay, last up is the idea of parallel and perpendicular. So let's start with parallel. Write the equation of the line parallel to the one given that passes through 4, 7. All right, parallel lines have the same slope. So what that means is the slope of our parallel line will also be 4. What we need to do is just replace x1 and y1 with this new ordered pair given. Y minus 7 equals 4, parentheses, x minus 4. Done. Easy as that. As far as perpendicular, we're going to write the equation of the line perpendicular to the one given that passes through 3, negative 1. Perpendicular lines have opposite reciprocal slopes. If I can spell reciprocal. So what I mean by that is opposite is the sign change. So if it was a positive 4, it's going to become negative 4. And then reciprocal is, if you think about this as over 1, it becomes 1/4. So our new slope will be negative 1/4. We have our new slope. We have our new point. Just plug in our point and our slope. Y minus negative 1, so it's actually y plus 1, equals negative 1/4 quantity x minus 3. Done. And that's it for tonight. Thank you.